Okay, so a girl is flying a kite on a string. The kite is 100 feet above the ground, and the wind is blowing the kite horizontally away from her at 5 feet per second. At what rate must she let out the string when 150 feet of string has been let out? So let's draw a quick diagram. So this is the girl and her kite. So from this we could draw a triangle, and we could label it X, Y, and Z. And it also says that she has let out 150 feet of string, so we could label that as Z. Now, before we go any further, we could solve for X. So now we could plug in 150 for Z and 100 for Y. And let's plug that in. And we get approximately 111.8. So that's X. The question also says the kite is moving horizontally away from her at 5 feet per second. So that means that this is moving at 5 feet per second. And you could also write that down here. It makes it easier to see. Okay, now we could set up Pythagoras theorem. And let's differentiate it with respect to time on both sides. So we're going to get 2x dx over dt plus 2y dy over dt equals 2z dz over dt. So let's see what we have. So we have x. We also have dx over dt because this is the rate at which the kite is moving horizontally, which the question gave us. So this is dx over dt. We have y. We also have dy over dt. In the question, it says that the kite is moving horizontally away from her. So you could assume that the kite isn't moving up or down. So then dy over dt equals 0. We also have z, and we're looking for dz over dt. So now we could plug in some numbers. So 2 times 111.8 times 5 plus 2 times 100 times 0 equals 2 150 times dz over dt. So this whole thing will be 0 because it's multiplied by 0. And if we isolate for dx over dt, we'll be left with 2 111.8 times 5 over 2 times 150. So let's plug that in. So we get 3.73. And don't forget the units, feet per second. A boat is being pulled into a dock by a rope passing through a pulley on the dock, which is positioned 6 meters higher than the boat. If the rope is being pulled in at a rate of 2 meters per second, how fast is the boat approaching the dock when it is 12 meters away from the dock? Okay, so let's draw a quick diagram. So that's the boat. Here's the dock. And it says that the pulley is 6 meters higher than the boat. So we could label that. It also says the boat is 12 meters away from the dock. So we could also label that, and we'll complete the triangle. So let's find the missing side length. So z squared equals x squared plus y squared. Z equals root x squared plus y squared equals root 12 squared plus 6 squared. So let's plug that in, and we're left with 13.42 meters. So let's write that. Now in the question it says that the rope is being pulled in at a rate of 2 meters per second. So that would be this side length. So let's label them x, y, z. So dz over dt equals 2 meters per second. So what is the question asking? The question is asking how fast is the boat approaching the dock when it is 12 meters away from the dock? So that would be dx over dt. Also, we could assume dy over dt equals 0 because the pulley is fixed. So now let's set up Pythagoras. Now we'll differentiate with respect to time. So 2x dx over dt plus 2y dy over dt equals 2z dz over dt. So we have x, we're looking for dx over dt, we have y, we have dy over dt, it's 0, we have z, and we have dz over dt. So we'll be able to solve this. So if we arrange for dx over dt, we're left with 2z dz over dt minus 2y dy over dt divided by 2x. So let's plug everything in. So 2 times 13.42 times 2 minus 2 times 6 times 0. So everything will go to 0 there. And 2 times 12. So if you plug all that in your calculator, you'll be left with 2.24 meters per second. And that's the answer for that one. Two people are at an elevator. At the same time, one person starts to walk away from the elevator at a rate of 3 feet per second, and the other person starts going up the elevator at a rate of 7 feet per second. How fast is the distance between the two people changing 20 seconds later? So let's draw a diagram. So this is the elevator, and it says the person is moving up at a rate of 7 feet per second. So this is 7 feet per second. And it says the other person is walking away at a rate of 3 feet per second. So this is 3 feet per second. So this question is asking for how fast the distance between the two people is changing 20 seconds later. So let's start off by getting each of their positions 20 seconds later. So distance equals velocity times time. So for person A, the distance will be 3 feet per second times 20 seconds. You can see the units will cancel and we'll be left with 60 feet. So let's draw that. So this is for person A, and they're moving away at a constant speed of 3 feet per second. Distance B will be 7 feet per second times 20 seconds. So that'll be 140 feet. This picture is not to scale, but, and we could label their speed because it's constant. And let's complete the triangle. So let's label this X, Y, and Z. So in that case, this speed will be dy over dt, and this speed will be dx over dt. Now we could find z using Pythagoras. So let's isolate for z, and we just have to plug in x and y. So it's 60 and 140. So let's plug that in the calculator. And we're left with 152.3 feet. So 152.3 feet. So the question is asking how fast is the distance between the two cars changing? So we're looking for dz over dt. Because at this moment in time, person B is over here and person A is over here. So we're trying to find how fast this line is increasing. So again, let's set up Pythagoras. Differentiate with respect to time on both sides. So dx over dt plus 2y dy over dt equals 2z dz over dt. So let's see, we have x, that's 60. We have dx over dt, 3 feet per second. We have y, 140 feet. And we have dy over dt, which is 7 feet. We have z, and we're looking for dz over dt, so we'll be able to solve this. So let's start plugging in some numbers. 2 times 60 times 3 plus 2 times 140 plus 7 equals 2 times 152.3 over here times dz over dt. So let's start plugging that in. So you'll be left with 2,320 there and 304.6 times dz over dt. Now if you isolate for dz over dt, you'll be left with 7.62. And again, what are the units? It's going to be distance over time, so feet per second. Okay, a 20-foot ladder is leaning against the wall, with the base of the ladder 5 feet away from the wall. If the top of the ladder is slipping downwards at a rate of 2.5 feet per second, at this instant, what is the rate at which the bottom of the ladder is moving away from the wall? So let's say this is the wall, and this is the 20-foot ladder leaned up against it. It says the base of the ladder is 5 feet away from the wall, so we'll label that as 5 feet. And let's label the triangle, so x, y, z. Let's solve for y. So let's just plug that in. So if you plug that in, you'll get 19.36. And let's remember, these are units of feet. So let's write that. Okay, and the last piece of information is the ladder is slipping downwards at a rate of 2.5 feet per second. So that means that this side of the ladder is moving down at that rate. And this would be dy over dt because it's in the vertical direction. So what is it asking? It's asking the rate at which the bottom of the ladder is moving away from the wall. So if this side is coming down, this side will naturally have to go right. So we're looking for dx over dt. Now let's set up Pythagoras again and differentiate with respect to time. We're left with 2x dx over dt plus 2y dy over dt equals 2z times dz over dt. So we have x, which is 5. We're looking for dx over dt. We have y. We have dy over dt. We have z, and we actually do have dz over dt. So imagine we have a ladder against the wall. If it's starting to slip down, the length of the ladder doesn't change. So this would still be 20 feet. So no matter what angle the ladder is leaned up against the wall at, it'll always remain the same length, 20 feet. So that means dz over dt equals 0. Now let's start plugging in. So 2 times 5 times dx over dt plus 2 times 19.36. And be careful for dy over dt. Since this part is moving down, this is a negative. So we should have defined up and right as positive. So yeah, that's negative 2.5 equals 2 times 20 times 0. So this is all 0. Now let's just isolate for dx over dt. So that'll be 2 times 19.36 times 2.5 over 2 times 5. Just plug that in the calculator, and we're left with 9.68 feet per second. Notice how the answer is positive. This is because the ladder is moving right, which we defined as positive. So this answer makes sense. Okay, the speed limit on a street is 50 kilometers per hour, and there's a speed camera fixed 10 meters above the road. When a car passes the camera, the speed at which the straight line distance between the camera and the car is increasing at 5 kilometers an hour. There's a typo. The car is 3 meters horizontally away from the camera. Is the car exceeding the speed limit? So this is the car, and the speed camera is 10 meters above the road, so let's label that. Here's speed camera. It says the car is 3 meters horizontally away from the camera, so that would be this side length. It says the rate at which this straight line distance is 5 kilometers per hour. So this is z, x, and y. So right away I could already tell that dy over dt will be 0 because the camera is fixed in place. And dx over dt is what we're looking for. So first let's find the side length z, because we're going to need that. So that's going to be 3 squared plus 10 squared. So that's 10.44 meters. Now let's set up Pythagoras, and let's differentiate with respect to time again. So 2x dx over dt plus 2y dy over dt equals 2z dz over dt. So now let's just plug it in. Plus 2 times 10 times 0. This will all go to 0. Equals 2 times 10.44 times 5 kilometers an hour. So now let's isolate for dx over dt. We'll be left with the right side over 2 times 3. So let's plug that in. And we're left with 17.4 kilometers per hour. So comparing to the speed limit of 50 kilometers per hour, they are going well below the speed limit. So no, they are not exceeding the speed limit. So thanks everyone for watching. Let me know if you have any questions in the comment section, and please subscribe.